So for number 7, we are finding the domain and finding the vertical asymptotes. So for the domain, remember all you care about is just the denominator. And so we take the denominator, which is x squared minus 7x plus 12, and we are looking for the excluded values. So the values that are going to make it 0. So to do that, I'm going to factor it. So x squared minus 7x plus 12. What two numbers multiply together to get me positive 12 and add up to get negative 7? And that is negative 3 and negative 4. So I have my two factors. It's set equal to 0, so now I can split them up. And so now I can solve. So I add 3 to both sides. And so x can't be equal to 3. I add 4 to both sides, and x can't be equal to 4. So my domain is just that. So for all x values, x cannot be equal to 3 or 4. Now the only difference with the vertical asymptote, you're essentially doing the same thing, but the only difference is we are going to simplify it. So when we simplify it, we have to actually factor the top as well. Even though it doesn't really matter when we start solving, but to simplify, we need to factor the top. So x squared plus x minus 20 factored is x plus 5 times x minus 4. We already factored the denominator here, so x minus 3 times x minus 4. And we're going to cancel out any like factors. So x minus 4 and x minus 4 are like factors, so we can cancel those out. So we still only care about the denominator. So even though we factored the top, we still only care about the denominator, but now we care about the denominator now that it's simplified. So same thing, we take the simplified denominator and set it equal to 0, and we get our equation, x is equal to 3. So my vertical asymptote is at x is equal to 3. So the only difference, like I said, between the domain and the vertical asymptote is the domain is looking at everything in the denominator, where the vertical asymptote is looking at it once it's simplified. So for number 8, we are now looking at the horizontal asymptotes. Remember, with the horizontal asymptotes, there are 3 rules that you need to know. And all of the rules have to do with the degree of the polynomial in the numerator versus the degree of the polynomial in the denominator. So if we're looking at A, the degree of the numerator, remember it's the highest degree, so it's the highest exponent here, is 2. And then the degree of the denominator is 1, because my highest exponent is just 1 there. And so the degree of the numerator is greater than the degree of the denominator. Now, remember I kind of tried to show you like my trick when we did the quiz of the way I think of it. I cover up everything, and I just look at x squared over x. So I'm looking at x squared over x. And so then if I were to simplify that, the x in the bottom would cancel out to just be x. And that's like a normal function that doesn't have any horizontal asymptotes, and so that is what we have. Oh, it's not y, it's none. So there are no horizontal asymptotes. So when the degree of the numerator is higher than the degree of the denominator, we don't have a horizontal asymptote. Okay, so for B, we do the same thing. We look at the degree of the numerator, which is the highest exponent, which is 2. And the degree of the denominator, which is again the highest exponent, which is 2. So when the degrees are equal to each other, we're looking at the leading coefficients. Now the leading coefficient of each of them is 1. So y equals 1 over 1, which simplifies to just be 1. So it's kind of like, I look at it the same way as I covered it up here. I still cover it up and I'm left with x squared over x squared. Now if I were to simplify that, those cancel out and I'm left with 1. Now if there were numbers in front like 2 and 4, I'd be left with 2 over 4, which is 1/2. So that's kind of the trick that I use to remember these. And then for our last one, C, the degree is of the numerator is 1, because that's the highest exponent, and the degree of the denominator is 2, because that's my highest exponent there. So now the numerator is less than the denominator. So for the horizontal asymptotes, when the degree is less than the numerator is less than the denominator, your horizontal asymptote is 0. So those are your 3 situations. You can either have none, no horizontal asymptote, y is equal to the leading coefficients, and then y is equal to 0. So at this point, again, we can look at it as 5x over x squared, and then we would notice, okay, the x squareds cancel. The x and the x squared cancels to just be left with like 1 over x, let's just say, well, 5 over x, but that's just like kind of the rational expressions that we were using before, and the rational expressions were always, our horizontal asymptotes were always at y equals 0. If that doesn't make sense, like the trick that I tried to show you over here, then I would definitely just have those memorized. So know the degree. When it's greater than, the numerator is greater than the denominator, it's none. When they're equal, use the leading coefficients, and when the numerator is less, then it's 0. Okay, so for number 9, it says use synthetic division to determine if x plus 2 is a factor of this whole thing. So that means what we want is the 0 of my factor, which is x plus 2, my factor. We want the 0 to be on the outside. So that means my 0 is the opposite sign, -2. So that's what's going to go on the outside of the house, and on the inside are going to go my coefficients. So they do go in sequential order. So you can put your headers up there if you want, or you don't have to. So for x to the 4th is 1, x cubed is 11, x squared is 4, x is 37, and -77. So remember, to determine if it's a factor, my remainder has to be 0. So if it's a factor, my remainder will be 0. If it's not a factor, my remainder won't be 0. So we're going to go through the process of synthetic. Bring the 1 down. 1 times -2 is -2. 11 plus -2 is 9. 9 times -2 is -18. 4 plus -18 is -14. -14 times -2 is 28. 37 plus 28 is 65. And 65 times -2 gets me -130. Now when I add those together, you can already tell, even though it's -207, we can already tell this is not going to be, my remainder is not going to be 0. So because my remainder is not 0, it is not a function, or not a factor. So if this was 0, then your answer would be yes. But because this is not 0, your answer is no. And that does it for number 9. Okay, so for number 10, this is like very similar to what we did on your quiz. So I did a very similar one on the video from the quiz study guide. You can use your quiz to practice this one. There's a lot of different ways that you can practice this one. So we have given the function, blah, 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 find the x and y intercepts. So I'm just going to start off by looking at my x-intercepts. Now with this one, unlike the future ones, it's factored for you. So that means, remember, our x-intercepts are where y is equal to 0. And y is always the same as f of x. So that means I'm going to set my whole function, x minus 1 cubed, x plus 2 squared, and x plus 4. I'm going to set it equal to 0 because I'm going to set my y equals to 0. So now that I have it equal to 0 and I have it already factored, then I can just set all of my factors equal to 0 to solve. Oops. There we go. Okay, so we have these cubes, squares, all that, and I can just undo the cube by cube rooting it, and cube rooting 0. Well, the cube root of 0 is just 0, and so x minus 1 equals 0, and then add 1, we get x is equal to 1. Now, this next one is squared. So to undo the squaring, we're just going to square root it. Square root one side. Sorry, you have to square root the other side. So then we have x plus 2 equals 0, because the square root of 0 is just 0. We would subtract 2, and x is equal to negative 2. Now for this one, we don't really have to worry about anything. There's not an exponent there, and so we can just subtract 4 and get x is equal to negative 4. So those are my 3 x-intercepts. My x-intercepts are 1, 0, negative 2, 0, and negative 4, 0. And that's just by setting each factor equal to 0. And then for my y-intercept is where x is equal to 0. So it's the opposite, right? So that just means into our function, we're going to plug in 0 for x and solve for y. So 0 minus 1 cubed, 0 plus 2 squared, and 0 plus 4 is going to get us our y-intercept. So negative 1 cubed is negative 1. 0 plus 2 is 2, and 2 squared is 4, and then 0 plus 4 is just 4. Now, I don't know why, but for some reason, some of you like to add these. There's no adding signs. When they're next to each other and there's parentheses, that means we are multiplying. So negative 1 times 4 gets me negative 16. So 0, negative 16. Okay, so now for part B, we're looking at where we're determining whether the graph touches or crosses at each x-intercept. So remember, when we're finding that out, oh, there goes my pen. When we're finding that out, we are basically looking at the multiplicity. And remember, the multiplicity has to do with the exponent of each factor. So my 0, x is equal to 1, the factor was x minus 1 cubed. So that cubed, that exponent there, is giving me the multiplicity. So the multiplicity of 1, my 0, 1, is 3. Now 3 is an odd number, and when the multiplicity is odd, that means it crosses through the graph at the x-intercept. So 1, 0 would cross. So then my next 0, which is x is equal to negative 2, the factor that we looked at was x plus 2 squared. So my exponent is 2, so my multiplicity is 2, which is an even number. Now, when the multiplicity is even, that means it hits the x-axis at the graph and then it bounces back. And so that's where it touches. It touches at negative 2, 0. And then the last one, my 0 is negative 4. That factor is just x plus 4. Now, there is no exponent there, so when there's no exponent there, we assume the exponent is 1. So the multiplicity is 1, which 1 is, again, an odd number. And so when it's odd, that means it crosses through at the x-axis, crosses through to the other side. Okay, so then to determine the end behavior of the graph is looking at the degree of the function and then the leading coefficient of the function. So the degree of the function, so let's look at our original function. The degree, remember, when it's not multiplied out, so that means when there's the parentheses there, that's when we add the exponents up. When it is multiplied out, like our next problems are multiplied out, like this does not have any parentheses, that's when you take the highest exponent. So all we do is add our exponents, 3 plus 2 plus 1 to get 6. So my degree is 6, which is an even number, and my leading coefficient, now there is no number in front of it, so we can assume it's 1. And so my leading coefficient is 1, which is a positive 1. So that part, the even and the positive, is what's going to tell us the end behaviors. So when it's an even degree and a positive leading coefficient, we are increasing to the left and increasing to the right. So remember, you have different rules there. If it was even and negative, it would be decreasing and decreasing. If it's odd and positive, then it would be decreasing and increasing. If it was odd and negative, then it's just flipped. It would be increasing and decreasing. So again, it's kind of another thing with the multiplicity. You have to kind of memorize that when it's odd, it crosses, when it's even, it touches, and for this, you have to just probably have memorized the end behaviors. Okay, so then determine the maximum number of turning points. The maximum number of turning points is just looking at the degree and subtracting it by 1. So our degree is 6. 6 minus 1 is 5. Easiest part there. And so then to sketch the graph, all we're going to do is we're going to take all of our points that we found. So we found our x-intercept, so I'm always going to plot those first. So we have 1, 0, negative 2, 0, and negative 4, 0. And then I'm going to plot my y-intercept. I know my y-intercept goes off the graph, but I am going to give it a good shot. It's like about down here somewhere. And then we're looking at, okay, so we know it's increasing to the left and it's increasing to the right. I also know at 1, it crosses, and at negative 4, it crosses. And then at negative 2, it's going to touch that x-intercept and then bounce back. So I would usually just kind of gauge it from there. I know it has to come back, touch the negative 2, touches it, bounces back, goes through my y-intercept, comes back up, and crosses through that x-axis. And then you have your graph. Remember, honestly, I don't know where this all goes down to, this turning point goes down to. It doesn't matter. You can use your graphing calculator to help you get a better sketch if you want to. You know, it can also help you to check your work, but to me, I just kind of follow this. I'm not really looking for this. What I'm looking for is your x-intercepts, that they cross through at the appropriate places, it bounces at the appropriate places, where your y-intercept is, and then your end behaviors follow what you wrote down above. So that should wrap up. I don't know what number we're on. I think we're on 10, so that should wrap up 10.